Okay, welcome to this video. This is the steps for chapter 10e, trigonometric equations continued, basically. So there's 4 steps which I would like you to pause the video and copy down now. And I will, once you've copied the steps down, I will talk you through what each one of them means with the following example below. So definitely worth you pressing pause and copying everything down. Okay, so the equation we have to solve is sine 3x equals a half. Now this is trickier than a normal question because until now we've not had what we call this linear transformation. So this is like sine of something that's in the form y equals mx plus c. So we have to deal with how we solve these. So step 1 is change your boundaries. See, the boundaries we are given are just for x, but we're going to be taking answers for 3x. So what we do is we replace our x with a 3x, and because getting from there to there involves timesing by 3, we take each one of our boundaries and we times them by 3. So 0 times 3 is still just 0, but then 360 times by 3 is going to give you 1080. So that was step 1, change your boundaries. Change to 3x because we have 3x in here. Step 2 is to use your trig button. So because this is all nicely, there's nothing in front of that sign, the next thing that needs to happen to inverse this, to find that x, is to get rid of that sign. So we just use our calculator and we just use our normal inverse sign of a half. Hopefully we all know that that is 30 because I go on about it all the time. So I get 3x equals 30, and that, to get from there to there, what I've done is inverse sine. And this is your principal solution, the first one your calculator gives you. Then the next thing we need to do is find all of our solutions according to our new bounds, because as we know, 30 is not just the answer. And I'll show you how to do this using both methods. If you were to do it using the cast diagram, then here is our principal, our first, there's our 30, and we know that sine was positive, so there's another solution of 30 here. So as I'm following this round, my first solution is 30, then my next one is 150, then one complete loop would take me to 360, so I add 30 more, that takes me to 390, then I keep going. If I take my 360 and add another 180 over here would be 540. So that is going to be 510. I keep going, and I know that this would also be 720. So my next solution is 30 more from that, which is 750. And then if I were to add another 180 to that 720, that would give me 900 over here. So this one here is 30 before 900, 870. And then I can see my next one over would be my 1080, would stop just here. So I would be finished. If I wanted to do that using the sine curve, then I would need to realise that I'm going to need lots of repeats to go all the way up to 180. So to 1080. So here is my 180, here is my 360, there is my 540, there is my 720, there is my 900, and there is my 1080. So my half was here, so my first answer was 30 there, so this distance matches this distance, gives me my 150, same distance here, gives me my 390, same distance here, gives me my 510, same distance here, 750, same distance here, 870, and then we're finished. So that was step 3, find all the solutions in my new bounds, and then I actually need to solve for x, because you can see here that this is actually 3x. So I just want my solutions for x. Well, to turn 3x into x, I would just divide by 3. So all I need to do now is take each one of those solutions and divide by 3. 30 divided by 3 is 10. 150 divided by 3 is 50. 390 divided by 3 is 130. 510 divided by 3 is 170. 750 divided by 3 is 250. And 870 divided by 3 is 290. And they are all of your answers. So what's really important is this stage here, the one where you had to change your bounds, because if I didn't make those bounds larger, I would only have got these first two solutions. And because actually I'm solving for 3x, all of these numbers here were in my original bounds for x, because we were scaling down, because it's 3x, not just x. So we needed to make sure, it's so important that you change your bounds on these questions. I will pop up 2 more examples for you to watch after this, and then have a go at 10e. Hope that helped.